with our organometallic compound, chapter 15. So this is a reaction where you're going to synthesize an acetylenic alcohol, either from using acetylene or using a terminal alkyne. So this is the generic formula for this. So you're going to have a triple bonded carbon pair and an OH group in the same compound. Your R groups can either be hydrogen, alkyl group, an aryl group, or a vinyl group. So we've got a lot of variation. We're starting with an example where you have acetylene, or it could be a terminal alkyne. You're going to use your sodium amide, ammonia, just like you would in an alkylation, to form your salt of the acetylene. So this is our organometallic compound in this case. We'll take our organometallic compound, the bond between the sodium and this carbon is going to break. It's going to come over here and link up with the carbonyl carbon. The pi electrons here are going to rotate up to this oxygen, and then these electrons are going to receive a hydrogen from your hydronium acid that you have in this step right here, so that you're going to end up forming this molecule. So this came from your terminal alkyne or acetylene, and this came from the acid off of the carbonyl carbon. This just shows you another example where you're going to be using a Grignard reagent. So the first thing you would do is you're going to remove the hydrogen off of here, and that's going to create a Grignard reagent with the triple bond associated using the diethyl ether. Once you get this, then you're going to take this carbon. It's going to attach to the carbonyl carbon, so in this case it was formaldehyde. So it doesn't have to be a ketone, it could be a formaldehyde, any aldehyde, or a ketone. And then, of course, your hydronium ion is going to provide the hydrogen for your final product. And again, you don't have to use an organometallic, a Grignard reagent. You can use a lithium compound as well. So your organolithiums can be used as well. Now, if you are making alcohols and you want to figure out what you needed to make that alcohol, you can kind of work your way backwards, starting from the target molecule and then going back to your starting material. So let's look at kind of a simple example. If this is my alcohol, then this carbon has 3 other functional groups attached to them. It could be hydrogens, it could be benzene rings, whatever they are. So basically, I could break off any one of these and add it to my Grignard reagent or my lithium compound to create my organolithium compound. And then what remains, wherever this is going to become my carbonyl carbon. So if I break off this top one, as in this case, then this is going to be attached to my Grignard reagent or my lithium compound. And then the remaining part of this will be given back, of course, to the hydronium ion, and your carbonyl carbon would go here. So if you look on the next slide, you're going to do the deprotonation, as we mentioned. And here's my Grignard reagent from the top substance that we broke off, and then the substance that was remaining that still had the OH group becomes the carbonyl carbon once you deprotonate back to that hydronium ion. You have the potential of 3 possibilities, because these, if I left this attached and then I broke off this one, that could go with my Grignard reagent, and all of this would then go with my carbonyl carbon. And the same is true if I break this off, that would go with the Grignard reagent, and then these would all go together to form the carbonyl carbon complex. So if you look at this example, if I break off this methyl group, I'm going to get the methyl and then the Grignard reagent here, and everything else, so the benzene ring, the carbon with the alcohol is going to be my carbonyl carbon, and then the ethyl group here. If I break off this, my Grignard reagent is going to attach to the benzene ring, so I'll have the benzene ring with the Grignard reagent, and then everything else, which will be a 4-carbon compound, where this would be my carbonyl carbon, would be my other compound in this reaction. And then, of course, if I break off here, I'll have an ethyl group that goes with my Grignard reagent. And then all of this would go together, this being my carbonyl carbon, so I'd have my ethyl group with my magnesium bromide, and then I would have my acetophenone. There's two other reactions that we're going to look at. The first one involves an organocopper reagent that's called the Gilman's reagent. And you're basically going to make an alkane or some type of a alkyl benzene, depending on what you started with. The reagent itself is a lithium dialkyl cuprate, so that means you're going to have two alkyl groups that are identical, a copper and a lithium compound all complexed. This shows you how you create that, but we're not going to worry about how you make it. We just want to start with it. The solvents that you would use in this process would either be diethyl ether or your tetrahydrofuran. So we'll look at a specific example. Before we do that, just kind of as a general, again, you can have alkyl groups here or aryl groups. If you start off with alkyl groups, you're going to get an alkane. One of the alkyl groups is going to attach to the alkyl group of the alkyl halide. The other alkyl group is going to attach to the copper, and then the lithium is going to pick up the halogen. If it's an aryl group, meaning a benzene ring of some sort, then it's going to pick up the alkyl group off of the alkyl halide, forming an alkyl benzene. Your other aryl group is going to go with your copper, and then your lithium, of course, is going to pick up the halide. So there's same basic processes, just a little bit different in the actual compound you make in the end. So here is an example. If we have this compound, we have this as our R group. This would be the R group here, so you actually have a vanillic halide. So this vanillic halide is going to pick up this butyl group. The other butyl group is going to link up with the copper, and then the lithium is going to pick up the bromine. And this one just shows you an example if you have an aryl halide. So this will be my butyl group is going to be attached to my benzene ring. So this will be my alkyl benzene. My next thing, my copper would be picked up by the other butyl group, and my lithium by the iodine. The last reaction we're going to look in this chapter is using an Organozinc reagent to make a cyclopropane derivative. The reagent we use is called the Simmons-Smith reagent, and this is the general formula for it, or it can be written this way, which it usually is. It's an iodomethyl zinc iodide compound, or you can write it this way, which is actually how you produce it. So the next little part just shows you how you get it, but we're not too interested in that process, but you can see on this slide how it's produced. Here's an example. So you're going to start off with an alkene. That's key. So you start off with an alkene. Wherever the alkene is, those pi electrons are going to break, and that's where the cyclopropane is going to form. These are stereospecific, so if I start off with an alkene that is cis, then I'm going to form a cis cyclopropyl product. If I start off with one that is trans, as in this case, I'm going to get a trans cyclopropane product. So these are all the reactions that we're going to do in chapter 15.